Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next video. In this video, dear students, we are going to solve 8 further problems about integration. Okay. All these 8 problems have been selected or chosen from the book Calculus Early Transcendentals by James Stewart, Slim Watson and Daniel Clegg. All these 8 problems are solved under the technique substitution method. Okay. Evaluate the integral by making the given substitution. Okay. In each problem, a substitution is proposed, and using that proposition we will solve these 8 problems. Okay. First problem, integration of cos 2x dx, where substitution is u equal to 2x, while last problem, that is problem number 8, is integrate z into square root or under root z minus 1 into dz, while substitution is u equal to z minus 1. Okay. Dear students, as usual, before coming to its solution in a formal manner, we will first go to several snapshots which are copy paste versions, which will provide us a foundation regarding the understanding of these 8 problems. Okay, so first snapshot is about the table of indefinite integral. Okay. Yes, students, our 8 problems will be solved according to these formulas. Okay. All these formulas will not be used definitely. These are more formulas, while our problems are only 8. However, our all 8 problems will be covered from these 8 formulas. Okay. For example, dear students, this formula will be used. Integration of 1 over x dx is equal to log into absolute value of x plus c. Okay. Similarly, integration of cos x dx is equal to sin x plus c. This formula will also be used, and some more formulas will also be used. Okay. Next, table of integration formulas and other version. Okay. Almost all those formulas are somewhat less or more have been chosen from another book. Okay. Almost these are same as in the previous slide. Okay. Anyhow, these are total 20 formulas. Okay. Our 8 problems will be covered from these formulas. Okay. There is nothing special to be explained. Okay. We go forward. Okay. This is another formula. Okay. This formula is included in above 2 tables, but here this formula is given in a more comprehensive way as a separate theorem. Okay. The general power rule for integration. Okay. That is to say, in integration we increase power by 1, and then that increased power appears in the denominator, and we add a constant c. Okay. Moreover, denominator must not be equal to 0, because division by 0 is not allowed. This is a basic principle of mathematics. This is some detail about the concept of substitution rule. Okay, substitution rule and the substitution rule for definite integrals. Okay, in case of definite integrals, we are taking limit from a to b, while in 4 number definition or concept, this limit has not been taken. Okay. Now, dear students, these examples will also help us a lot in solving those 8 problems. Actually, these problems are exactly as those 8 problems. Okay, we are just showing these examples in order to develop a confidence regarding the solution of these 8 problems. Okay, so that we can decide easily that we are going to solve our problems correctly. Okay, so dear students, in this example we are going to substitute 5x plus 1 by u, then we will find du by dx, and from here we will find simply value of du. Okay, which is will be equal to 5 into dx, and 5 into dx appears in the problem statement. So in place of 5 dx we will use du, and in case of secant square 5x plus 1 we will use secant square u. Okay, so next we will solve we will apply the formula for u, and after solving this problem we will again substitute u by 5x plus 1. Okay, so that the given statement is solved exactly. Okay, this is, dear students, this is another example. Okay, here, dear students, we will take u x cube as u, then we will find du by dx. Okay, so du will be equal to 3 into x square into dx. In the problem x square dx appears, so x square dx will be equal to 1 by 3 du. Okay, so simple 1 by 3 du, and in place of x cube we have used u. Now we will solve this simply, because 1 by 3 is constant, we will take 1 by 3 as outside the sign of integration, and then we will solve this according to the formula. We know that integration of cos u is sin u. Okay, and then after solving we will again re-substitute u by x cube. Okay, similarly, dear students, in this example we will substitute x square plus 1 by u, and therefore du by dx will be equal to 2x, and hence 2x into dx will be equal to du. Okay, so this statement will be substituted as u raised to power 50 into du. Okay, we will solve this according to this formula. Okay, and after solving we will again substitute u by its original value x square plus 1. Okay, here in the next example we will use x plus 9 as x plus 9 equal to u, then du by dx will be equal to 1 plus 0, that is 1. That is to say, in this case dx and du will be both equal. Du will be equal to dx. Okay, so our given problem will take the form as u raised to power yes, our problem will become sin u du, and we know that integration of sin u is minus cos u, so our answer will become minus cos u plus c, and here once again we will re-substitute u by its original value, that is x plus 9. In the next example we will substitute x minus 8 by u, and here once again du and dx will be equal, so our statement will be reshaped as integration u raised to power 23 into du. We will solve it as per power rule, that is to say power will be increased by 1, and then that increased power will appear in the denominator, and a constant will be added c. Okay, and now after solving we will again substitute u by its original value. Okay, here dear students, we will substitute 5x equal to u, and then du by dx will be equal to 5, will become equal to du by dx will be equal to 5, and hence 5 into dx will be equal to du, or 1 by 5 du will be equal to dx. Okay, so in place of dx we will apply 1 by 5 du, and in place of cos 5x we will use cos u, and we will solve it according to u. Okay, 1 by 5 is constant, so it will be written prior to sign of integration, and we know that integration of cos u is sin u. Okay, differentiation of cos u is minus sin u, but integration of cos u is plus sin u. Okay, so 1 plus 5 sin u plus c, and we have solved this problem up to this step, that 1 by 5 sin u plus c, but here we will again replace u with its original value, that is to say 5x. Okay, this is another version of the above problem. Okay, this is the same problem as above. Example number 3, cos 5x dx. The only difference is there that here dx is equal to 1 by 5 du equal to 5 dx, exactly same, only typing difference is okay. Now next in next example we will substitute 1 by 3x minus 8 by u, then we will find du by dx, then dx will be equal to 3 du. Okay, so in place of dx we will use 3 du, and in place of 1 by 3x minus 8 we will use u. So our given statement will be reshaped as integration 3 du by u raised to power 5. Here 3 is constant, so it will be written prior to sign of integration, and then u5 which is in the denominator will appear in the numerator, but its power will be reversed, that is to say we will get u raised to power minus 5, and then we will integrate it according to power rule, that is to say power will be increased by 1, that is to say it will become minus 4, because when we will add 1 in minus 5, then it will become minus 4, and similarly this minus 4 will appear in the denominator. So to this extent our problem is solved, but the only thing remaining is that here we will once again substitute u by its original value, that is to say 1 by 3x minus 8. Now we come towards our original main 8 problems, which is the focus of this video. Okay, problem number 1, cos 2x dx. Here substitution is u equal to 2x. Let u equal to 2x. This implies that du by dx will be equal to 2, and hence this implies that dx will be equal to du by 2, half du. Okay, so in place of dx, dx is equal to du by dt, du by 2. This implies that cos 2x dx will be equal to cos u, because in place of 2x we have used u, and in place of dx we have used du by 2, which we have found above. Okay, so here 1 by 2 is constant, so it will be written prior to sign of integration. So half integration cos u du, we know that integration of cos u is sin u. Okay, differentiation of cos u is minus sin u, but integration of cos u is plus sin u. So in the last we will again substitute u by its original value, that is 2x, and hence our answer will become 1 by 2 sine 2x plus 2, 1 by 2 sine 2x plus c. Problem number 2. Integration x e raised to power minus x square dx, where u is equal to minus x square. We have to use this substitution. When u is equal to minus x square, then this implies that du by dx will be equal to minus 2x, and hence this implies that x dx will be equal to du by du over minus 2. So x dx appears in the problem statement, so we will use du by minus over minus 2 in place of x dx, and in place of e raised to power e raised to power minus x square, we will use e raised to power u. Okay, now according to formula of integration, first this minus 1 by 2, which is a constant, will be written prior to sign of integration. So minus 1 by 2 will be taken out, and we will get integration eu into du, and we know that integration of exponential function is exactly same as it is, no change. This formula is contained in the snapshot which we have shown in the beginning of this video. Okay, so minus 1 by 2 e raised to power u plus c, this is our answer. But the only step remaining is that here we will once again resubstitute u by its original value, that is minus x square. So our answer will become minus 1 by 2 e raised to power minus x square plus c. Problem number 3. X square square root under root square root or under root x cube plus 1 into dx, where substitution which we need to use is u equal to x cube plus 1. Okay, when u is equal to x cube plus 1, then this implies that du by dx will be equal to 3x square, and from here x square into dx will be equal to du by 3, because x square dx appears in the problem statement. So we will substitute x square dx by du by 3, and we will substitute x cube plus 1 square root as u square root. Okay, we know in the next step we know that square root or under root is equal to power 1 by 2. Moreover, 1 by 3 is a constant, so it will be written prior to sign of integration, and then we will apply power rule. That is to say, this power 1 by 2 will be added by one number, and this added power or exponent will appear in the denominator. Okay, so power or exponent is increased by 1, that is 1 by 2 plus 1, and same figure, that is 1 by 2 plus 1, will appear in the denominator. Okay, moreover we know that half plus 1 is equal to 1.5, that is 3 by 2. So our next step becomes 1 by 3 u raised to power 3 by 2 over 3 by 2 plus c. Okay, now dear students, in the denominator we will get 9, and we know that fraction in the denominator is reversed. That is to say, denominator of the denominator appears in the numerator. So in the next step we will get 2 by 9 u raised to power 3 by 2 plus c. To this extent our problem is solved, but the only step remaining is that here we will resubstitute u by x cube plus 1. Okay, in place of u we have written x cube plus 1. Remaining answer is the same as in the previous step. Problem number 4. Integration of sine square theta cos theta du substitution which is proposed or suggested is u equal to sine theta. When u is equal to sine theta, then du by d theta will be equal to cos theta, and from here du will be equal to cos theta into d theta. And we know that in the problem statement cos theta and d theta appears. So in place of this cos theta d theta we will use du, and in place of sine square theta we will use u square. Okay, problem solved. Next step, we know that here power rule will be applied. That is to say, this power or exponent 2 will be added by one number, and this addition will also appear in the denominator, and simultaneously a constant will be added. Okay, so we will get u raised to power 2 plus 1 divided by 2 plus 1. So it will be equal to 1 by 3 u raised to power 3 plus c. To this extent our problem is solved, but here the only step remaining is that here we will re-substitute u by its original value, that is to say sine theta. Okay, so our answer has become 1 by 3 sine cube theta plus c. Problem number 5. X cube over x raised to power 4 minus 5 dx, where proposed substitution given in the statement is u equal to x raised to power 4 minus 1. Okay, when u is equal to x raised to power 4 minus 5, x raised to power 4 minus 5, then du by dx will be equal to 4 into x raised to power 3. This is power rule of differentiation. Okay, so in these problems we are using a power rule of differentiation and somewhere at the power rule of integration. Okay, in power rule of differentiation, power is reduced by 1, and that reduced exponent or power appears as a multiplying factor. But in the integration, which is the reverse process of differentiation, power or exponent is increased by one number, and that increased power or exponent appears in the denominator. So when du by dx is equal to 4x3, then this implies that x raised to power 3 into dx will be equal to 1 by 4 du, because x cube into dx appears in the statement. So in place of x cube dx we will use 1 by 4 du, and in the denominator in place of x raised to power 4 minus 5 we will use u. So our substituted statement will become in sign of integration x cube over x raised to power 4 minus 5 dx. This becomes equal to sign of integration 1 by u into 1 by 4 du. Here 1 by 4 is constant, so it will be written prior to sign of integration. So our reshaped statement will take the form as 1 by 4 sine of integration 1 by u du. Now we will apply the rule of integration. According to rule of integration, 1 over u is equal to log absolute value or modulus value or mod of u. Okay, it will become equal to 1 by 4 log absolute value of u or modulus value of u or mod u plus c. To this extent our problem is solved. However, the only step remaining is that we will re-substitute u by its original value x raised to power 4 minus 5, and hence our answer will become 1 by 4 log absolute value of x raised to power 4 minus 5 plus constant c. Problem number 6. 1 by x square 1 by 1 over x square into square root or under root 1 plus 1 over x dx. Here proposed substitution is u equal to 1 plus 1 over x. Okay, that is to say a quantity given inside the square root or under root has been substituted to be taken equal to u. Okay, so when u is equal to 1 plus 1 over x, so du by dx will be equal to d over dx into 1 plus 1 over x. Here 1 over x is equivalent to writing x raised to power minus 1, so its differentiation will be equal to minus x raised to power minus 2, and this is equivalent to writing minus 1 over x square. Okay, so when du by dx is equal to minus 1 over x square, so du will be equal to minus 1 over x square into dx. And moreover, if we multiply minus on both sides, then we get minus du equal to plus 1 over x square dx, because plus 1 over x square into dx appears in the problem statement. So in place of 1 over x square into dx, we will substitute minus du. Okay, and in place of square root 1 plus 1 over x, we will use u. Okay, so our substituted statement form will take the form as minus sign of integration u square root or under root into du. Okay, now this is here, dear students, this is equal to u square root or under root or u raised to power 1 by 2, one and the same thing, there is no difference. So instead of u square root or u under root, we have written u raised to power 1 by 2, because we are going to apply power rule of integration, and in power rule of integration we know that power or exponent is increased by one number, and then that increased power or exponent also appears in the denominator, and simultaneously a constant sign is added, a constant of integration is added. So we will get a minus u raised to power 1 by 2 plus 1, and this 1 by 2 plus 1 will also appear in the denominator. So in the next step we will get u raised to power 3 by 2, because we know that half plus 1 is equal to 1.5, that is 3 by 2. So 3 by 2 power of u and 3 by 2 in the denominator, and we know that fraction in the denominator is reversed, that is to say denominator of the denominator appears as numerator. So our answer will become minus 2 by 3 u raised to power 3 by 2 plus c. To this extent our answer is complete, but the only step remaining is that in place of u we have to resubstitute u by its original value, that is to say 1 plus 1 over x. So our answer becomes minus 2 by 3 1 plus 1 over x raised to power 3 by 2 plus c. Next problem number 7, in sign of integration cos square root or under root t over square root or under root t into dt. Proposed substitution is u equal to square root or under root t. Okay, so dear students, when u is equal to t square root, then du by dt will be equal to d over d2 into t square root or under root, and t square root or under root is equivalent to or equal to t raised to power 1 by 2. And we know that now we are going to apply power rule of differentiation. In power rule of differentiation, power or exponent is reduced by one number, and then that reduction also appears as a multiplying factor. So dear students, 1 by 2 minus 1, yes, this 1 by 2 appears as a multiplying factor, that is to say first 1 by 2, then t raised to power 1 by 2 minus 1. Okay, and in the next step t when minus 1 is greater, half is less, so minus half will be the result of this subtraction. Okay, so we will get 1 by 2 t raised to power minus 1 by 2, and we know this power minus 1 by 2 will be shifted to denominator, and it will become as power plus 1 by 2 in the denominator, and this power 1 by 2 is also equivalent to square root or under root, so it will be equal to 1 over 2 into t square root or under root. Okay, this is equal to, actually this is the value of du by dt. From here du will be equal to the same quantity or amount into dt. Because dear students, in the problem statement, moreover this implies that 1 over t square root into dt will be equal to 2 du, and we know that in problem statement dt over t square root appears. Okay, so in place of dt over t square root or t under root, we will write 2 du, and in place of cos t square root we will use cos u, because t square root or t under root has been substituted by u. So our substituted form will become sine of integration cos u into 2 du. Here 2 is the constant, so it will be written prior to sine of integration, and our next step will become 2 sine of integration cos u into du. We know that integration of cos u is sine u, okay, while differentiation of cos u is minus sine u. Okay, so we will apply formula of integration, and we will get 2 into sine u plus c. To this extent our answer is complete, but the only step remaining is that in the last we will once again resubstitute u by its original value, that is t square root or t under root or t raised to power 1 by 2. So our answer will become 2 into sine t square root or 2 or t under root or t raised to power 1 by 2 plus c. Problem number 8. Sine of integration z into square root or under root z minus 1 into dz. Here substitution proposed in the problem statement is u equal to z minus 1. That is to say, a quantity or amount given in the square root is substituted by u. So when u is equal to this, then du by dz will be equal to 1, and when this becomes equal to 1, then both are equal, that is du is equal to dz. Okay, and from here when u is equal to z minus 1, then if we find the value of z, then z will be equal to u plus 1. So our given statement will take the shape as sine of integration z into z minus 1 square root or under root dz becomes equal to sine of integration u plus 1 into u square root or under root into du. Okay, dear students, here u square root or under root will be multiplied with two terms within the parenthesis, and our substituted form of statement will become sine of integration into u raised to power 3 by 2 plus u raised to power 1 by 2, because u power 1 plus power 1 by 2 will become 1.5, that is 3 by 2. Okay, so then we will distribute sine of integration over these two adding terms. This is also called linearity. Okay, in mathematical terminology, this arrangement or this step is sometimes also called as linearization. Okay, anyhow, this becomes equal to sine of integration u raised to power 3 by 2 into du plus sine of integration u raised to power 1 by 2 du. Okay, to this extent we have not integrated, we have just rearranged our problem statement. Now in the next step we are going to apply the rule of integration, power rule of integration. That is to say, power or exponent will be increased by one number, and then that increased power or exponent will appear in the denominator. Okay, this this trend will apply on both these terms, and simultaneously a sign of integration will also be added as per rules of integration. Okay, so we will get u raised to power 3 by 2 over u raised to power 3 by 2 plus 1, and also divided by 3 by 2 plus 1, plus u raised to power 1 by 2 plus 1, and also divided by 1 by 2 plus 1, plus sign of integration c. So we know that 3 by 2 plus 1 is equal to 5 by 2. So 5 u raised to power 5 by 2 divided by 5 by 2 plus u raised to power 3 by 2 divided by 3 by 2, plus sign of integration integration constant c. Here, dear students, we know that a fraction in the denominator is reversed and denominator of the denominator appears in the numerator. So so in the next step we will get 2 by 5 u raised to power 5 by 2 plus 2 by 3 u raised to power 3 by 2 plus c. To this extent our problem is solved. The only step remaining is that here we have to resubstitute u by its value, that is z minus 1. Okay, so our answer becomes 2 by 5 z minus 1 power 5 by 2 plus 2 by 3 z minus 1 power 3 by 2 plus c, where c is a constant of integration. This is the end of our problem. This problem is 8 problems. This is the end of our video. Till next video, Allah Hafiz.